We're in business. All right, number classifications. Like I said, you've been doing this since you were probably, they introduced integers to you. So, what is the smallest out of our list? Are irrational, rational, whole, integer, natural, real, and complex. What is the most restricted? Natural. So we're going to put natural here in the middle. I think about my son. A natural number is a number that is natural to him. So when he was real little, like a toddler, he understood one sucker. I can have two suckers. I can have 3 pieces of cheese. He understood 1, 2, 3, 4. He did not understand 0. It did not make sense to him. Somebody had cheese. Somebody had suckers. He tried to convince his high school, non-driving high school age babysitter to walk with him down a very busy road to Kroger to get him more cheese because we were out. So as a little kid, you don't understand 0. Now, a little bit bigger than natural. Where do we go there? Whole. What is the difference between whole numbers and natural numbers? 0. Notice whole has an O in it. And so 0 is a part of it. Natural does not have 0 in it. It does not have an O in it, so 0 is not a part of it. I don't know if that helps you remember it or not. Now, so it's 0 plus and all natural numbers. So there's no natural numbers that aren't considered whole numbers. All right, a little bigger than whole. Out of our list, where do we go from there? Integers. Now, do we have any integers that are not, or are there any whole numbers that are not integers? No. What does integers bring to the number set that whole and natural did not? Negatives. So we're going to do our 3 little dots. So -3, -2, -1, and all whole numbers. Okay, a little bit bigger than integers would be what? We've got irrational, rational, real, and complex left. What do we think? We've got integers. Let's go with rational. Rational numbers are actually part of, or are also called the quotient group. What does quotient mean? We found a quotient. What would we do? Division. So the rational numbers are any number that can be written as a fraction. So rational numbers, any number that can be written as a fraction. Really need to give myself a little bit more room there. So a rational number is anything that can be written as a fraction. The symbol or the letter that we use for rational is Q for quotient. It's kind of a Q and it's got a little line in the edge of it. Natural, you'll see an N, it's kind of like an equal sign, the other part of the N. Now, if you're not rational, who are you? No, we better not say it that way. If it isn't rational, then it would be considered irrational. So you cannot be rational and irrational all at the same time. Give me examples of irrational numbers. Pi. Repeating, what about, let's go, I forgot to write that in. Repeating decimals, where would they fit? That would be considered rational, like 0.3 repeating is what fraction? 1/3. So repeating decimals, we're going to put that down here under rational. What about 0.5? Can you write 0.5 as a fraction? Yes. So repeating decimals, terminating decimals, so then what would irrational numbers be? Why did we say pi? It doesn't repeat and it doesn't end. So non-repeating, non-terminating decimals. What else other than pi? Square root of 3. Like it. What else? What about the square root of 4? Why not? Because it equals 2. So actually the square root of 4 is natural, isn't it? It's also a whole number. It's also an integer. It's also a rational number. What about the square root of 1/4? Square root of 1/4. What would that equal? I heard it. 1/2. So where would that fall? That would be rational. So the square root of 1/4 is equal to 1/2. So it would fall under rational numbers. What about the square root of 10? That would be irrational, because there's nothing times itself that would give me 10. Now, a little bit bigger than rational or irrational, or if I were to put rational numbers plus my irrational numbers, so everything that is in this purple box, what would we consider that to be? Real. So my purple box represents real numbers. There aren't any numbers that aren't a rational or irrational that are in the purple box, or that aren't in one of those two boxes that are real. So real is basically rational plus irrational. Okay, if we're not real, then what are we? We're not, okay, we're fake. I don't know if that's what we said. I thought that's what we said. If we're not real, if it's not real, then where does it exist? In your imagination. Or in its imaginary numbers. So we have real versus complex. Complex numbers are imaginary. They don't exist in real life. Now, I want you to think about back to quadratics, where you did parabolas, you had x squared, you had the quadratic formula. Where did we come up with no real solution? That was our answer. When did we answer that? No real solution. What do you think? Yes. That is an imaginary number. So square root of -1 is equal to I. I has a very special value. It's equal to the square root of -1 all the time. So when you make your I, it needs to be stripped. It needs to have a tail that kind of flips to the right. That makes it look different than just kind of a variable. So if I had the square root of, what is the square root of 4? 2. So the square root of -4 is equal to the square root of -1 times the square root of 4. Are we okay with that? What's the square root of -1? I. What's the square root of 4? 2. So the square root of 4, negative 4 is equal to 2i.
Is that I recognized in all of math or
Yes.
just that problem?
No, it is recognized in all math. That's a very good question.
Okay, so there's numbers for like pretty much all of those, like that have been set aside. Okay.
E has a very special value as well.
Okay.
But it will always equal square root of negative 1. And pretty much from here on out, there is actually an entire class devoted to complex numbers in college. So computer science, I believe, is one that uses a lot of complex numbers. Maybe electrical, I don't know. But that's a number system or a number classification. Questions on that? So you're going to have to be able to classify numbers. Are we okay there?